This is November 2015, standard level, paper 1, question 7. And it's about arithmetic sequences, but everything's written in terms of natural logarithms. So these are the sorts of questions towards the end of section A, where they bring in together different areas of mathematics that are really designed to be able to tell the 6 and the 7 students apart from the 4 and the 5 students. An arithmetic sequence has the first term log A. I'm going to write that down in the notation that we used to use in log A. And a common difference of log 3. The 13th term of the sequence is 8 log 3. So it's 8 log 9. So there's all the information given in the question, and we've got to find the value of A. Oops, that's not what I want to do. Trying to find the value of A there. So the sensible thing to do is to use our formula for UN and write down U13. U13 is equal to U1 plus 13n minus 1 d. U1 we know is log A. 13 minus 1 is 12. D we know is log 3. And we know that U13 itself is equal to 8 log 9. So that's all the knowledge really of sequences that we need to apply. And now it's just a question of, can we solve this equation for A? And we have to use our log laws. So let's take the 12 log minus 3, let's subtract that from both sides. Now there's lots of different ways you can do this. The order of these steps, you can do them. People will have done them differently. But you will end up having to do the things that I'm doing at one point or the next. So by doing that as our first step, we're that much closer to isolating A. A is nearly on its own. It's inside a logarithm. We'll deal with that in a second. And the easiest way to deal with that is to combine all of this into a single logarithm, log of some number. And the easiest way to do that, or the first step towards doing that, is to bring these powers up. So instead of 8 log 9, I get log 9 to the 8. And instead of 12 log 3, I get log 3 to the 12 is equal to log A. Next step, again there's a couple of options. I'm going to go with turning the 9 into a 3. So 9 is the same as 3 squared. So instead of writing log 9 to the 8, I'm going to write log 3 to the 16. And then the rest is unchanged, equals log A. And then I can use my division law that log A, let's not use A, so that's going to confuse things. Let's write the division law like this. Log X minus log Y is the same as log X over Y. So instead of log 3 to the 16 minus 3 to the 12, I can write it as one logarithm. 3 to the 16 over 3 to the 12 is equal to log A. And now, because it's written as a single logarithm, I can sort of ignore the logs and say, well, if the logs are equal, then the numbers inside the logs must be equal. Or another way to think of that is I'm doing e to the power of both sides to cancel out the logarithms. However you think about it, you get to this step, 3 to the 16 over 3 to the 12 is equal to A. We know how indices work. If you divide 3 to the 16 by 3 to the 12, then all that happens is you subtract the indices. 16 minus 12 gives you 3 to the 4. And I think if you'd written a is equal to 3 to the 4, that would be enough to get the point. But I can evaluate it. 3 times 3 is 9, times 3 is 27, times 3 is 81. And that's our value for A. So the way marks are allocated here is there's a method mark for doing this substitution and an accuracy mark for setting it equal to 8 log 9. And then because you can do them in any order, the next 3 marks are all awarded sort of independently. 1 for doing the powers, using the power rule. 1 for using 9 is equal to 3 squared. Or you could have done it the other way around, and I could have written 3 to the 12 is the same as 9 to the 6. And I'd have ended up with the answer 9 squared is 81 if I'd done that. And then the last accuracy mark is for using this log law, log x minus log y. Lots and lots and lots of different approaches to this. The order that you do things in can be very different, but however you do it, you should always get to the answer 81.